Hello students, I am Dr. Satish Chauhan, your chemistry teacher. I welcome you in the video lecture 7. In this video, we will learn molecular orbital energy level diagram for the formation of O2 molecule, O2 minus ion and O2 2 minus ion. Let us begin our story from molecular orbital energy level diagram for the O2 molecule. This molecule is formed by the combination of two oxygen atoms. Each oxygen atom has electron configuration 1s2, 2s2, 2p4. The 1s orbital is lower energy orbital and hence it does not take part in chemical bonding. Thus, in 1s orbital remains as non-bonding molecular orbital. Only 2s orbital and 6 2p orbitals of the two oxygen atoms, that is total 8 orbitals, form total 8 molecular orbitals. Here 2s and 2p orbitals of oxygen atom are close in energy, so they interact with each other, and the sequence of energy of level of molecular orbital is given as sigma 2s less than sigma star 2s less than sigma 2px less than pi 2py is equal to pi 2pz less than sigma star 2px less than pi star 2py is equal to pi star 2pz. The remaining 12 electrons of the oxygen atom, these are filled in molecular orbitals following above principle and Hund's rule of maximum multiplicity. The first two electrons are filled in sigma 2s bonding molecular orbital. Next two electrons are filled in sigma star 2s bonding anti-bonding molecular orbitals. Two electrons occupy sigma 2px and the 4 electrons are filled into the pi 2py and pi 2pz orbitals. The remaining 2 electrons go to the pi star 2py and pi star 2pz orbitals. Let us consider the energy level molecular orbital energy level diagram for the formation of oxygen molecule. This is an energy axis. Let us consider the 2s and 2p orbitals of oxygen atom 1. These are the 2s and 2p orbitals of oxygen atom number 2. The 2s orbitals combine with each other and give rise to the molecular orbitals, that is sigma 2s bonding molecular orbital and sigma star 2s antibonding molecular orbital. Similarly, 2px orbital of the 2p orbital from both oxygen atoms combine together and give rise to the sigma 2px bonding molecular orbital and sigma star 2px antibonding molecular orbital. Similarly, 2py and 2pz atomic orbitals from both oxygen atoms combine together and give rise to the pi 2py and pi 2pz bonding molecular orbitals and pi star 2py and pi star 2pz antibonding molecular orbitals. Pi 2py and pi 2pz atomic orbitals have the similar energies or equivalent energies, so these are called as degenerate orbitals. Similarly, pi star 2py and pi star 2pz molecular orbitals will have the equivalent energy, and therefore these are called as the degenerate orbitals. There are 2 electrons in the 2s orbital of oxygen atom 1 and there are 3 electrons in the 2p orbital of oxygen atom 1. Similarly, there are 2 electrons in the 2s orbital of oxygen 2 and there are 3 electrons in the 2p orbital of oxygen 2, which gives rise to the formation of O2 molecule. The 2 electrons are filled in sigma 2s molecular orbital, that is bonding molecular orbital. Then 2 electrons are filled in sigma star 2s antibonding molecular orbital. 2 electrons are filled in 2px molecular orbital. 2 electrons, these are also filled in 2py, pi 2py molecular orbital and pi 2pz molecular orbital. Remaining 2 electrons are filled in pi star 2py and pi star 2pz molecular orbitals, antibonding molecular orbitals with parallel spin. Hence, there are 2 unpaired electrons in the antibonding molecular orbital, and there are 8 electrons in the bonding molecular orbital and 4 electrons are present in the antibonding molecular orbital. Let us calculate the bond energy and bond order for oxygen molecule. The molecular orbital electronic configuration of oxygen molecule can be written as Kk sigma 2s2, sigma star 2s2, sigma 2px2, pi 2py2, pi 2pz2, pi star 2py1 and pi star 2pz1. The energy evolved is calculated by using the formula the number of electrons in bonding molecular orbital into minus beta plus number of electrons in antibonding molecular orbital into plus beta. So that is equal to 8 into minus beta plus 4 into plus beta, that is equal to 4 beta. The bond order of this molecule can be calculated by using the formula bond order is equal to 1/2 number of electrons in the bonding molecular orbital minus number of electrons in antibonding molecular orbital, that is equal to 1/2 into bracket 8 minus 4 is equal to 2. So there is double bond in oxygen molecule. It contains 1 sigma and 1 pi bond. It has bond length 1.21 angstrom and bond energy 118 kilocalories per mole. Let us consider the paramagnetism of oxygen molecule. In oxygen molecules, we have seen that there are 2 unpaired electrons with parallel spins in the degenerate antibonding pi molecular orbitals are present in pi star 2py1 and pi star 2pz molecular orbitals. This distribution of 2 unpaired electrons in the antibonding molecular orbitals is according to the Hund's rule. Oxygen shows paramagnetic properties. The molecular theory gives very simple explanation for the presence of 2 unpaired electrons and hence the paramagnetism of the oxygen molecule. Oxygen is paramagnetic due to the presence of 2 unpaired electrons in the antibonding pi molecular orbitals. It is very difficult to explain the paramagnetism of oxygen molecule with the help of valence bond theory. Valence bond theory assumes that sharing of electrons between the 2 oxygen atoms for the completion of the octet configuration of each oxygen atom in the oxygen molecule. According to VBT, oxygen molecule should be diamagnetic, but in practice it is paramagnetic. Molecular orbital theory explains the paramagnetism of oxygen molecule. The effect of number of electrons in the antibonding molecular orbitals in bond lengths and bond lengths in diatomic species of oxygen. Let us consider O2 minus ion. O2 minus ion is also called as superoxide ion. This is an example of molecular species. It has one electron more than electrons in the oxygen molecule, and it has 17 electrons. Its molecular orbital representation is kk sigma 2s2 sigma star 2s2 sigma 2px2 pi 2py2 pi 2pz2 pi star 2py2 pi star 2pz1. The bond order of O2 minus ion can be calculated as 1/2 into bracket 8 minus 5, that is 1.5. Thus, there is one sigma bond and one 3 electron bond in O2 minus ion. The bond order has decreased from 2 in oxygen to 1.5 in O2 minus superoxide ion. Bond length of oxygen O2 minus ion has decreased from 1.21 angstrom in oxygen molecule to 1.26 angstrom in O2 minus ion. The ion has unpaired electron, and hence the ion is paramagnetic in nature. Let us consider the another ion, that is O2 2 minus ion. O2 2 minus ion is called as peroxide ion, and it is usually present in sodium peroxide or hydrogen peroxide. It is formed by the addition of 2 electrons to the oxygen, that is O2 plus 2 electrons, that gives O2 2 minus ion. It has 2 electrons more than the electrons of oxygen molecule, and it has 18 electrons. Its molecular orbital representation is kk sigma 2s2 sigma star 2s2 sigma 2px2 pi 2py2 pi 2pz2 pi star 2py2 and pi star 2pz2. The bond order can be calculated as 1/2 into bracket 8 minus 6, that is equal to 1. The bond order has decreased from 2 in oxygen to 1 in O2 2 minus peroxide ion. The bond length of O2 2 minus ion has increased from 1.21 angstrom in oxygen molecule to 1.49 in O2 2 minus ion. The ion has no unpaired electrons, hence it is diamagnetic in nature.